Hello, everyone. This is the last day of limits. So whenever you are watching this, whether it's on Tuesday when I'm dating it, or next week, or Monday, regardless of when you're watching it, it's the last day of limits, and you have one more worksheet to do. All right, so today's goal is we're going to determine net change and average rate of change. We've already looked at average rate of change earlier in the year at the beginning, so that's just going to be a little bit of a refresher. And then we are going to look at the difference quotient again, except now we are going to apply it as h approaches 0, which will relate to your calculus endeavors at some point. All right, so for this first one, I'm giving you the function x squared minus 6x plus 9. I've given you the graph, and the dashed blue lines are both secant lines. So if you recall, a secant line is a line that intersects a curve at 2 points. So we are going to find net change, and we are going to find the average rate of change. So net change is only the vertical change. Or the change in the y value as you move from one point x to the other point x. So we are doing this one on the interval 1 to 3. So we need to calculate a couple of values. You can probably see them on the graph. But if those points weren't nice points, you would need to be able to calculate them. So f of 1 is going to be equal to 1 squared minus 6 times 1 plus 9. If you calculate that number, you have 1 minus 6, negative 5 plus 9 is 4. So the next one we need to calculate is f of 3. You can see from the graph that it's sitting on the x-axis. But just to make sure, we're going to do 3 squared minus 6 times 3 plus 9. So f of 3 is equal to 9 minus 18, negative 9 plus 9, which is 0. So we have calculated this point, 3, 0. And we have calculated this point, 1, 4. So we're looking at the secant line between those 2 points. But when we look at net change, the only thing we want to see is that we're going from 1 to 3 on our x value. So that is a drop of 4 units. So your net change is going to be f of 3 minus f of 1, which is 0 minus 4, which is a negative 4. So what that represents is f of x drops 4 units from x equals 1 to x equals 3. All right, so there's net change. So now we're going to transition over into average rate of change. So ROC is going to stand for average rate of change. So that is the slope of the secant line. From x equals 1 to 3. Okay, so average rate of change we did way back at the beginning of the semester. So I think it was maybe on the second test. So the average rate of change, the slope of that line is negative. So we need to make sure that we're going to get a negative slope out of this. So we're going to do f of 3 minus f of 1 all over 3 minus 1. So even if I did it the other way around, f of 1 minus f of 3 over 1 minus 3, I'm still going to get a negative value if you remember how slope works. So f of 3 is equal to 0, sorry. What am I doing? F of 3 is equal to negative 4. Sorry, I was looking at that value instead of these values up here that I need to use. So f of 3 is equal to 0, so 0 minus 4 over 3 minus 1, which is 2, which is negative 4 over 2, which is negative 2. So from the values x equals 1 to x equals 3, the average rate of change for the slope of the secant line is negative 2. So average ROC rate of change is negative 2 from x equals 1 to 3. Okay, so that is the line that has the negative slope that you can see on there, that secant line. Okay, so we're going to use the same function, except now we're going to go from 4 to 7. So that net change okay, so remember this net change should be positive because we're starting at 4, we're going to the right 7, and that y value is increasing. So f of 4, if we plug that in, is going to be 16 minus 24 plus 9, which is negative 8 plus 9, which is 1. F of 7 is going to be 49 minus 42, which is 7. 7 plus 9 is 16. So my net change is f of 7 minus f of 4, which is 16 minus 1, which is 15. So f of x increases by 15 units from x equals 4 to x equals 7. So from here to here is a positive 15 units. Okay, so the slope of the secant line, or average rate of change, so keep in mind I have 4, 1 here, and I have 7, 15. So change in y over change in x for slope. So f of 7 minus f of 4 all over 7 minus 4, which is going to be 16 minus 1 over 3, which is going to be 5. So average rate of change is 5 when x equals 4 to 7. So that math isn't too difficult. You should be able to do average rate of change and net change both given a function and just by looking at a graph if you know specific points. So there's a lot of things that apply to average rate of change. Okay, so average rate of change versus the difference quotient now. Okay, so this first graph is showing us average rate of change. So this point is A and f of A. This point right here is B and f of B. So average rate of change is simply the slope of the secant line from A to B, which is what we just looked at. Which is f of B minus f of A all over B minus A. So basically change in Y over change in X. Same thing you've been doing ever since you probably did pre-algebra. Okay, so if you recall, a difference quotient is where we were adding in that H value. So on this graph, this point is X, f of X. And then I'm adding a certain value of H for my secant line. So this value right here is X plus H for your X value, and f of X plus H. So difference quotient, if you recall, writing too fast. So difference quotient is, again, it's still the slope of the secant line, but it's going from X to X plus H with certain values. So in this case, we don't have numbers. So it would be f of the higher point, X plus H, minus the lower point, f of X. Those are your Y values. Over, it would be X plus H minus X, which simplified ends up to be f of X plus H minus f of X all over H. So this is still the slope of the secant line, except this ends up with an equation because we have X's and H's in our function. When we're doing the slope of the secant in this form, then we have numbers. So the only difference is the average rate of change uses numbers. So it uses numbers, sorry. And difference quotient uses X's and H's. Or doesn't have to be an X value, it could be anything. But typically it's going to have an H. So if you remember when I tried to explain this back, I think the second unit, these 2 points are going to squeeze in together, and eventually they're going to meet at a certain spot on this graph. So these 2 points will squeeze in and squeeze in and squeeze in as H approaches 0. And we might end up on the graph like right here. So then what this equation allows us to do is to find the slope of that tangent line wherever that point ends up as H approaches 0. So I'll have a better picture of that for you here in a bit. All right, so we're going to do a couple practicing the difference quotient. I kept them pretty straightforward, nothing too radical, so no square roots or cubic functions. Okay, so this part is pretty picky about the way you write things out, so make sure you pay attention. All right, so the first thing we're going to do is find the difference quotient for this. Okay, so the first thing you do is write the formula for the difference quotient. Then you plug in X plus H whenever you see any X's. If you remember, sometimes these get kind of long. Okay, so there is the piece f of X plus H. Now I have to subtract f of X, so be careful with your grouping symbols. Those of you that don't like to show work, you're going to get to redo this assignment until you show work. All right, so there would be the first step. Now it's just a matter of applying your algebra skills and simplifying. Okay, so be careful, make sure you don't make any sign errors such as addition or subtraction. Okay, so here I would have 2 times x squared plus 2xh plus h squared. So that's foiling out x plus h squared. Then I have minus 5x minus 5h. This is a plus. I did that when I did my notes too, I'm sorry. Okay, so that was plus 5x. Minus 3. So there's that first piece, f of x plus h. So then here you need to make sure you distribute your negative sign. If you remember, the goal here is to get rid of that denominator of h, because then we're going to substitute h equals 0 for the next step on this. Okay, so I still have my h in the bottom. So I have 2x squared plus 4xh plus h squared plus 5x plus 5h. I forgot my h there. Making all kinds of errors. Minus 3. That should be a plus 3. There's another error. Minus 2x squared plus 5x. So I've completely messed this one up. All right, so I need to go back and figure out where I messed up. Okay, so x plus h. This is plus 5x plus 5h minus 3. This should be a minus 5x right here. All right, I think I'm good now. Sorry about that. So 2x squared plus 4xh plus 2h squared plus 5x plus 5h minus 3 minus 2x squared minus 5x plus 3 all over h. Okay, so I would have found that error eventually because on this step, all of your terms should cancel out except for the terms that have an h in them. So my 5x's cancel, my positive 3 and my negative 3 cancel. So I'm left with 4xh plus 2h squared plus 5h. All over h. If I factor an h out of the top, where did I get 4x squared from? Holy cow. If I stop the video and I have to start the whole thing over again, so I don't really want to do that. So I have h times 4x plus 2h plus 5. Thought I'd made another mistake, but I didn't. H is canceled, so my difference quotient is 4x plus 2h plus 5. So this is the difference quotient right here. Okay, so now we're going to take one more step. If you look back at the directions. So now we're going to let h equals 0 and plug that in. So we get my final answer of 4x plus 5. Okay, so keep in mind that is my average rate of change for that function. So now what this allows me to do, here's the graph of that, just a rough sketch. I looks like this. Okay, so what that allows me to do, if I want to find my instantaneous rate of change at, let's say, x equals -2. Okay, so what happens is that function right there, 4x plus 5, lets me find the slope of the tangent line at x equals 2. That's called your instantaneous rate of change. Okay, so for example, when x equals -2, I have 4 times -2 plus 5, which is -3. So that is my instantaneous rate of change. At x equals -2. So it is the slope of the tangent line. Because now on that graph, we made h equal to 0. So those 2 points from the original secant line that we looked at the former graph where I explained that those 2 points were moving closer together. So now we can find slope anywhere on the graph using the equation 4x plus 5. Okay, so one more. All right, so we're going to have 3 over x, and we're going to let h equals 0. So f of x plus h minus f of x, I'll try not to make any mistakes on this one, all over h. So I'm going to have 3 over x plus h minus 3 over x all over h. Okay, so on this one, I need a common denominator for my numerator. So my LCD is going to be x times x plus h, because I need to be able to simplify that numerator in order to cancel out my h's. All right, so I need to multiply this one by x, and this one by x. This one is going to get multiplied by x plus h, and x plus h. So I still have my h on the bottom. I have 3x minus 3x minus 3h, if I distribute here, all over that denominator, and I go ahead and leave it factored, x plus h. Okay, so my 3x's cancel. So I'm left with -3h over x times x plus h. And I am going to multiply by the reciprocal of h, which is 1 over h. So my h's now cancel. My difference quotient is -3 over x times x plus h. There's the difference quotient. Now if x equals, or h equals 0, then I end up with -3 over x squared. So if you graphed that original function, now keep in mind there is a domain restriction that x can't be 0. So you could plug in any value for x and figure out the slope of the tangent line at that value of x on the graph of 3 over x. Okay, so that is called your instantaneous rate of change. Okay, so all of this will apply to limits as you start your calc class, whenever that may be. So hopefully it helps you kind of get started in that class and remember some of these things. So for now, it's the end of math analysis. There might be a project coming your way. I'm waiting to hear from Mr. Abundus on that. So, yep, let me know how I can help. basically you have until May 22nd to get caught up if you're behind. Have a great day.